Why do we have alpha waves, and what can they tell us? There are three main groups of alpha waves. The frequencies in the groups are 8, 10, and 12 waves per second. Alpha waves are of interest because they reveal how the brain works. The existence of the alpha groups confirms the two levels hypothesis. This hypothesis explains how the activity in the forebrain is organized. The functional units in the cerebral cortex are called columns. The two levels hypothesis states that the activity in a column is either at a high level or a low level. According to the hypothesis, just a few columns are active at a high level at a time. The rest of the columns have activity at a relatively low level. High activity in a column lasts only a short time. It gives us a continuous turnover of highly active columns. When the activity in one column has dropped from the high level, there is room for a new highly active column. The turnover leads to a flow of thoughts. Thanks to the alpha waves, it is possible to measure how long the high activity in a column lasts. The duration is usually somewhere in the range of 420 to 480 milliseconds. The number of highly active columns is alternating between a lower limit and an upper limit. The three alpha groups have different limits. These limits are 3 to 4, 4 to 5, and 5 to 6. A regulating system keeps the number of highly active columns between the lower and upper limits. The thalamic complex in the middle of the brain is perfectly placed for the task. Signals from the regulating system change the excitability of the columns. These changes create alpha waves. The onset of high activity is easy to detect because this onset gives rise to a peak. The green arrow indicates the beginning of high activity in a column. 4.5 waves later, the red arrow marks the end. The purple horizontal line shows the duration of high activity in one column. The beginning of high activity in a new column means that the number has changed to the upper limit. At this point, the regulating system begins to reduce the excitability of the low activity columns. The reduction of excitability occurs synchronously in many columns. The shift to a decrease gives a peak, which is detectable in an electroencephalogram. The high activity closes here, and the number returns to the lower limit. The regulating system then starts to increase excitability. A peak in the opposite direction becomes visible. The colorful horizontal lines represent high activity in individual columns. In this figure, the number alternates between 4 and 5. The regulating system has information about the number of highly active columns. The only way to obtain this information is by deciphering the alpha waves. It is hopeless to try to record the activity separately in all columns. We have to make use of the signals from the regulating system. To summarize this video, the number of highly active columns must be kept within appropriate limits. That is why we have signals from a regulating system. These signals are visible as alpha waves.